Hi guys, welcome to the Scientific Notation Workshop video. In this video, I'll be doing several scientific notation practice problems. So get out a whiteboard or a piece of paper and try these problems out with me in this video. You can pause the video once I give you a question. You can try to solve it on your own, and then you can watch the video and check your work and see what mistakes you make so that you don't make it on an assignment, test, or quiz. Okay, so let's get started. As a reminder, scientific notation is a way to write very large and very small numbers. It's always going to be some number times 10 to some power, to some exponent. Think about what scientists study. They study things that are really large in size, like space, or things that are really fast, like the speed of light. And they also study things that are very small, like bacteria, cells, and atoms. Positive exponents, so positive powers of 10, represent large numbers. Negative powers of 10 represent small numbers. And an important note, negative exponents do not mean negative numbers, okay? Negative exponents will be a very small decimal, but it's still a positive number. It's a number between 0 and 1. It's a number less than 1 whole, but it is not negative, okay? All right, so let's get started. We have this very large number, and when dealing with very large numbers, okay, it is hard to keep track of how many zeros. So when we're using scientific notation to rewrite very large and very small numbers, we're trying to get rid of this string of zeros here. There's too many zeros. It's easy to lose track of how many you have, or accidentally add an extra zero, or add a few more zeros. So we want to get rid of the string of zeros. So our focus is going to be the non-zero digits right here. We're going to use these three numbers to create our coefficient, which is the number in front of the times 10. Okay, now we have to put a decimal in our coefficient to create a coefficient that has a one-digit whole number. So if I put my decimal right here, for example, that is a two-digit whole number, 38. So you always want to create a coefficient that has non-zero digits, that has a one-digit whole number. So this is where my decimal is going to go, because this is a one-digit whole number plus some decimals. So 3.84. I'm going to draw in my decimal right here. Now our exponent is going to tell us how far away my new decimal is from the original location. All whole numbers do have a decimal. It's going to be at the very end, but we don't ever see this. So how many place values do I have to move my decimal? Some people just count the digits. 1, 2, 3, 4, 5, 6, 7, 8. So our exponent is going to be 8. Other people like to show the jumps like this. 1, 2, 3, 4, 5, 6, 7, 8. We moved our decimal place 8 times to the right. And that's another thing to note. Positive exponents represent very large numbers because you're moving your decimal place to the right, making this a very large number. Okay, and that's it. So 384 million written in scientific notation is 3.84 times 10 to the 8th power. Let's keep going. I'm going to try to, I'll be going pretty quick in this video because you can always rewind or pause and watch it again. 904,000. We're focused on all the non-zero digits. Now there is a zero inside here. Okay, we can't get rid of the zero because it's sandwiched between this 9 and the 4. So we want to get rid of the tail of zeros at the end. So 904 is going to be our coefficient. We want to put a decimal somewhere in here to create a one-digit whole number. That means it's going to go right here. Okay, so one-digit whole number. And then we have to see how many jumps to get to the original location. Again, you can count your digits in between, or you can do your hops. 1, 2, 3, 4, 5. So our exponent is 5. Positive 5, because it's a very large number, or you can do your jumps. 1, 2, 3, 4, 5. Our last very large number, we have 2,100,000. Let's focus in on those non-zero digits. We're trying to get rid of the string of zeros. 21. That is a 2-digit whole number, so remember we have to add our decimal to create a 1-digit whole number, 2.1. That's a little bit hard to see, but there's my new decimal place. Here's the original decimal place. How many place values did we move? 1, 2, 3, 4, 5, 6. 2.1 times 10 to the 6. You can also do your jumps if you'd prefer to do that. 1, 2, 3, 4, 5, 6. Okay, so this is the first example where we have a small number. When we have a small number, see that 0 in our whole number spot? This is a very small decimal. We know that our exponent is going to be negative. So I'm going to go ahead and put a negative sign. This also means we are moving our decimal place to the left now. So let's focus in on our non-zero digits right here. This is going to be our coefficient. Where can we put the decimal so that our coefficient is a number with 1-digit whole? Right here. Okay, I'm going to draw in my new decimal place. How far away is it from the original spot? 1, 2, 3, 4. You can also draw your jumps if you prefer. 1, 2, 3, 4. Okay, you see how we're moving to the left? So we're moving to the right for positive exponents because our number is getting larger. We can also think about this as the positive side of the number line is moving to the right. And when we're moving we'll move to the left. For small numbers, we can think about how the left side of the number line are the negatives. Okay, so our exponent will be negative. Our next example, 0.0000306. I see that string of zeros. I'm going to focus in on our non-zero digits. Remember that we do have to keep that 0 between the 3 and the 6 because it's sandwiched between. Where can we put our decimal place so that this is a coefficient with a 1-digit whole number? We're going to put it right here. There's always going to be a decimal. Unless this is just a single digit, so maybe not. But we know it's not going to go right here, okay, because that would be 30. Oh, I also know that this is going to be a negative exponent because this number is very small, so if you want to go ahead and do that. How many place values are between our original decimal location and our new coefficient? 1, 2, 3, 4, 5. This would be negative 5. Or if you prefer, again, you can always count your jumps. 1, 2, 3, 4, 5. Now, if you're someone who likes doing the hops, showing the hops, be very careful that you don't accidentally squeeze in 2 numbers between a hop. These hops are kind of like gaps. The number goes in between the gap. Okay, this one will be a great reason. You can see this is a really good number to change to use as scientific notation because there's way too many zeros. Is that 5? Is it 6? Is it 7 zeros? Let's look at all of our non-zero digits. This time there's 2 zeros between those non-zero digits, which is fine. We have to put a decimal somewhere in here to create a 1-digit whole number. Because right now it looks like 7,002. We want just 1-digit whole number. So our decimal place will go right there. What is the difference? How many place values are between our original spot and our coefficient spot? 1, 2, 3, 4, 5, 6, 7. So our coefficient is going to be, negative. Don't forget the negative because this is a small number. Negative 7. We can count your jumps if you prefer. 1, 2, 3, 4, 5, 6, 7. All right, so that we have now practiced writing very large and very small numbers in scientific notation. We also need to know how to write a number in standard form given it in scientific notation. 3.89 times 10 to the positive 4. This is a positive number, so I know that we're moving to the right, but also that this is going to be a large number. Okay, so let me show you some ways to do this. Some people, 3.89, Make this a little bit larger. Some people like writing in a lot of invisible zeros, plenty of invisible zeros after the decimal place, and using their mouse and moving using the arrow keys. This is we're moving 4 places to the right. So we start in our original decimal location. We can even take that away if you want, okay? So you start your mouse on the original location. When we move 4 places to the right, 1, 2, 3, 4, place your new decimal. Okay, so it was right here. We moved it 4 places to the right. And then you can get rid of all these extra zeros at the end. This is going to be a whole number. So there's your answer. We can then put in our comma. 38,900. That's one way. Others like to draw those hops. Okay, others start like this with the coefficient, and then they do their hops. 1, 2, 3, 4. They put their new decimal place, and then they fill in these gaps with zeros. Okay, this decimal is no longer there because we moved it. So then they rewrite it again, so that equals, here we can take off this decimal place because we moved it, 38,900. Okay, comma goes right there. One more method that we could do this is reasoning how many zeros you're going to be left with. Okay, so some people like thinking, all right, I have 4 jumps to the right. Now, when I'm jumping, I have to use one of those 4 jumps to get over the 8. I have to use another one of those 4 jumps to get over the 9. That means I've got 2 jumps left to use. So I know that I have 2 more zeros. So 4 jumps total, 1 over the 8, 2 over the 9, and then jump 3 and 4 will be over invisible zeros. Okay, so find a way that works best for you, where you're the most successful, and stick to that. There's a lot of different ways to approach almost everything in math. 1.2 times 10 to the 7th. Okay, so we can reason. Let's type this out. I don't know why it's so small. Okay, I have 7 jumps to the right. This is going to be a very large number. Some people think, okay, I've got 7 jumps. I need to use 1 jump to get over the 2. That's 1, 2, 3, 4, 5, 6, 7. Then we can fill in our number with commas. Okay. Did you all see how I did that? 1 jump gets over the 2. That means you have 6 jumps left, 6 zeros. Let me do it another way. We can start over here. Sometimes people just like adding several invisible zeros. Then using their mouse and arrow keys to go 7 jumps to the right. So I'm moving this decimal 7 jumps. 1, 2, 3, 4, 5, 6, 7. It's going to go right here. Then you can get rid of all those extra zeros at the end. You can even get rid of that decimal. And then we can fill this in with commas. Other people like to actually show their jumps. So we can do that. That's our coefficient. Let's show our jumps now. 7 jumps. 1, 2, 3, 4, 5, 6, 7. It's going to go right here now. And then we can fill this in with zeros. Our next example, we have a negative exponent. So I know this is going to be a negative number. That means we're moving our decimal to the left. So we need to start a little bit further to the right so that we have room to move to the left. Here is our coefficient. And we can hop to the left 5 jumps. 1, 2, 3, 4, 5. Here's our new decimal place. We can fill these gaps in with zeros. Now the only thing to think of for these decimals is that you will also have a 0 up front for our whole number spot. Okay, it's 0 whole. 0, so your answer is 0.000090044. Another way you can do it, if you want to go ahead and add in your zeros, we can do this. Instead of adding several zeros at the end, we're going to add several zeros in the beginning. You don't know necessarily how many you'll need, so just add a bunch of zeros like that. Start where your decimal is, and then move using your arrow keys 5 jumps to the left. So 1, 2, 3, 4, 5. Place your decimal, and then you can get rid of all those extra zeros that you don't need. Okay, so same answer. All right, I've got one more example for you here. 6.7 times 10 to the negative 8th. Okay. We can start first by drawing our jumps if you would like. 8 jumps. This is going to be a negative number. I mean, this is a negative exponent. Ooh, this is not going to be a negative number. It's going to be a small number because we're going to the left. 8. 1, 2. Ooh, hold on. I don't think I left enough space for my jumps. 1, 2, 3, 4, 5, 6, 7, 8. Ah! So your answer is 0.000000067. Let's do it the other way, where we prep several zeros, an abundance of zeros. 6.7. I'm adding zeros to the front because I know this is a small number with that negative 8. We can put our mouse where our decimal is, and then move it 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. Place your decimal. Get rid of all those extra zeros that you don't need. You will get the same answer. Okay, so I did several examples here. I did 10 examples. We did problems where we're changing from scientific notation to standard form. We did examples where we did standard form to scientific notation. We practiced very large numbers and very small numbers. If after you've watched this workshop video and you still feel like you need more practice on scientific notation, then please send me a message asking to work on scientific notation in office hours, and I would love to help you. So just let me know. But I hope this video was good practice for you and it helps. Bye, guys.